It's a continuation of what we had done in the previous video. Okay, again, solving part. Look at the first one. Tan inverse 2x plus tan inverse 3x is equal to pi by 4. You basically have to solve for x, right? So this is going to become tan inverse of 2x plus 3x by 1 minus 6x square. This is pi by 4. Take the tan inverse on the other side. So you will have 5x by 1 minus 6x square is equal to tan pi by 4, which basically becomes 1. Right? Once you have this, take the 1 minus 6x square on this side. Isn't it? So you have 5x is equal to 1 minus 6x square. Then 6x square plus 5x minus 1 is equal to 0. Now we need to split it. 3 and 2 we can take. But will it always work with 3 and 2? Think about it. So you have 6, but if you take 3 and 2, basically you have minus 6, correct? 3 and 2 might not work. Take 6 and 1. Okay, so you have 6x square plus 6x minus x minus 1. 6x into x plus 1 minus 1 into x plus 1 is 0. So you have x plus 1 into 6x minus 1 is equal to 0. Right? So you have x is negative 1 or x is equal to 1 by 6. Now that you have two values, which of them is going to work? Okay, which of them is going to work? Now substitute that. That is, substitute the first value minus 1. If you take negative 1, you have tan inverse of minus 2 plus tan inverse of minus 3. Isn't it? When you have this, you have tan inverse of minus 2 plus of minus 3 by 1 minus 2 into minus 3, which is 6. So you get tan inverse of minus 5 by minus 5, which is 1. You will get pi by 4. Same way, if you do it for 1 by 6 also, you will still get the same answer. Fair enough? So the answers for this question, negative 1 and 1 by 6. Right? Let's do the second problem now. See, in this one, show that sine inverse of this plus cos inverse of this plus tan inverse of this is equal to pi. Alright. Now, what we'll do, we'll take in a simple way. Convert everything in terms of one inverse trigonometric function. Either sine, cos or tan, it's up to your choice. If you want to convert everything into tan, go ahead and do it. If you want everything in terms of sine, go ahead and do it. It's all up to you. Fair enough? Personally, I would always convert into tan. It's easier. Okay? Because you have tan inverse of x plus y. Right? So it's easier if you convert it into tan, inverse tan function. So what we do? We convert the sine inverse in terms of tan inverse. Right? We'll make use of the basic trigonometry. Very, very basic trigonometry what you learned last year. That is, first what we'll do, we'll take a triangle. A simple triangle. Okay. See, if you have sine inverse of 12 by 13, let's call it as theta. Assume. So 12 by 13 becomes sine theta. Isn't it? Let's take this as theta 12, 13. Now we need to find the other side. We'll use Pythagoras theorem. Very simple. Right? So you will have this value, if you take it as x is going to be root of 169 minus 144. Okay, so you're going to get it as 5. Now, if you know the Pythagorean triplets, it's just a matter of like few seconds. 5, 12, 13 Pythagorean triplets. Very simple. Alright, so this is basically root 25, which is 5. So, what is tan theta? Tan theta will be 12 by 5, or theta is tan inverse of 12 divided by 5. So, sine inverse 12 by 13 is the same as tan inverse of 12 by 5. Right? Okay, likewise, we'll do it for cos. See that? Cos inverse of 4 by 5. Again, take cos inverse 4 by 5 as, let's say, 5, another angle. This becomes 5. Now, cos 5 is going to become 4 by 5. So, this is 4, 5. This is going to be 3, obviously. So, tan 5 becomes 3 by 4. So, 5 is tan inverse of 3 by 4. So, in place of cos inverse of 4 by 5, what can we write? Tan inverse of 3 by 4. And in place of sin inverse 12 by 13, we can write tan inverse of 12 by 5. Right? Let's substitute these values. First one is tan inverse of 12 by 5 plus tan inverse of 3 by 4 plus tan inverse of 63 by 16. Take any two of them together. Okay, so maybe I'll take these two first. Use tan inverse of x plus y by 1 minus xy formula. So we'll get tan inverse of 12 by 5 plus 3 by 4, 1 minus 12 by 5 into 3 by 4. Okay, now I know you can cancel off 12 and 4, but do not do it because LCM will become a problem. Keep it as it is. This becomes tan inverse of, so 5 into 4 is 20, 12 into 4, 48 plus 15 by 20 minus 36 divided by 20. 20 cancels. So you have tan inverse of 48 plus 15. So which is going to give us 63 divided by 20 minus 36, which is minus 16. Isn't it? So what do we have? 63 divided by minus 16. So in turn, what we are going to get now? So you have tan inverse of minus 63 divided by 16 plus tan inverse of 63 by 16. Right? So tan inverse of 63 minus 63 by 16 plus 63 by 16 divided by 1 plus this one 63 into 63 by 16 into 16. So tan inverse of 0. Tan inverse of 0 can be either 0 or it can be pi. Isn't it? So tan inverse of 0 becomes pi, which basically what we are trying to prove. Clear with this? So again I tell you, you can use sine inverse also or you can use cos inverse also. Here I use tan inverse. Not necessarily that you have to use tan inverse. You can choose any method you want. Fair enough? Let's do the third one. Look at this particular question. Okay, now here you have tan inverse of root x is equal to half cos inverse of, it is supposed to be 1 minus x by 1 plus x. Alright, so it's 1 minus x, not 1 underscore x. Okay, we'll do the substitution method and solve it. It's a much more easier way and direct way also. Okay, we'll substitute x is equal to tan square theta. You might be thinking, why square? Think about it. There's a root, right? How do you get rid of the root? By squaring it. That's why take tan square theta. Then you will get tan inverse of root of tan square theta half cos inverse 1 minus tan square theta by 1 plus tan square theta. Right? So what do you get? Tan inverse of tan theta is equal to half cos inverse of, what are you going to get here? You're going to get cos 2 theta, isn't it? So theta in this case is equal to half Cos inverse of cos 2 theta is 2 theta. So what do you get? 2 and 2 cancels out. You basically get theta is equal to theta, isn't it? So what is theta? So theta is going to be on the, see, we proved it with the help of taking substitution as LHS and RHS, correct? You can do the same thing with just RHS because the question says prove that, isn't it? By substituting, you can easily do it. That is, if you don't want to start with the LHS, because in some cases they don't prefer you starting on both the sides together. You can start from one side. Start from one side. Assume that I'm not starting with the LHS. That is, I'm starting only from the RHS. Alright. So if you are starting only from the RHS, we basically get theta, correct? Right? But what is theta from the substitution what we have taken? So you have x is equal to tan square theta or tan theta whole square. Root of x is equal to tan theta, isn't it? So what is theta? Tan inverse of root of x. So RHS theta is equal to tan inverse of root x, which is nothing but what we have on the LHS. So you can start by taking RHS, come to LHS, or you can take LHS, RHS separately and then prove that both of them are equal. Fair enough? So these are certain problems in inverse trigonometry, what you can see and what you can practice.